The only two examples I'm doing for you for this lesson are on graphing piecewise functions, because everything else in this lesson is about learning the characteristics of and recognizing the basic functions that the book focuses on. And they do focus on 12. So you might want to go through your study guide and put some sort of a marking system for yourself about which ones are in the book and which ones are not. Just to help you realize which ones to select from if you're using your study guide to answer the other questions in this assignment. Piecewise functions, I discovered first semester the new Algebra 2 textbook does not include, so I wanted to go over those with you in particular here. They're really simple. A lot of students find them really traumatizing, but they're really not bad at all. Okay. The first thing to do is to understand what you're seeing when you read this function, and the way you should read it is that this function is defined in two separate parts, so that for any value of x less than 0, the graph will be the absolute value of x graph. For any value of x 0 and to the right is going to be x squared. So the first thing I recommend you graph, and this is a very simple, basic little piecewise function. There's no rule about how many pieces you can have, and we'll be looking at a 3-piece one on number 52. The first thing I suggest you do is to put in what looks like a vertical asymptote, but it's not an asymptote. And this little program I'm using to make these videos doesn't have a dashed line, but this should really be a dashed line here. But in this case, our dividing line, which we are going to treat as a vertical asymptote just in terms of dividing the picture. That's all this line does. But remember, if it's not part of the graph itself, it really should not be drawn as a solid line. In this case, our vertical dividing line, or what you might want to think of roughly as a vertical asymptote, although it really is nothing at all like one, is the y-axis. So our focal point there just tells us which side of the picture we're going to work from. So we'll start on the left side, which requires that we graph the absolute value function. So let's switch to a blue color for our graph itself, and the absolute value function starting at 0 would be 0. So I'm going to plot a couple of points, and I'm going to plot the point at 0 with an open circle because of the fact that it's not equal to 0 there. All right, and then remember, when we graph the absolute value function, we would go to the left one and up one, and that's all we need because this graph is a straight line on that side. So I'm going to start at my open circle and go out and draw that line. Well, that's not a very straight line, so we're going to go back and actually use the line tool to get a decent approximation of this line here. So it would start at the hole and go out. Try that one more time. For some reason my line didn't form on the screen for me. So start at the hole and go straight out that line. So that's what that side's going to look like. And of course we should include the arrow at the end. And remember, you should always extend beyond the space provided when you graph any function. So now we're going to look at the right side, and we only graph the left side of the absolute value graph because that is the way this function is defined. So we have graphed the first piece. Now we're going to focus on the second piece, which is x squared. So now I'm going to go back, and I'm going to actually switch colors here to help you see what the distinctions are here. I'm going to switch over to a green color now, and when I plot or graph x squared, I start by plotting the vertex, which would be at 0, 0. So now this hole that I left open a minute ago is now going to get closed in by the other piece of the function. So then I go to the right one, up one. I go to the right two, up 4. And if I go to the right 3, let's see if I have room. I do. I can go up 9. Alright, so then I should draw the parabola. It should look a little flatter down here. So that's what this piecewise function looks like. And that's all there is to it. On to number 52, where now we have a three-piece graph. We'll notice that because of the fact that we have three pieces, we're going to have more vertical lines to separate our graph into than we had on number 50. And so -1 is the first one, and then 1 is the second one. So those are the two that I'm going to have to put on my graph to help me think straight. So I'm going to, again, put it in a color that I'm not going to use to help me realize that it's not actually part of the picture. So I'm going to go in a bright yellow this time, and I'm going to put a line at 1 and at -1, because that's the way this function was defined. And of course, if those numbers were like 2 and 6, then I would put these lines at 2 and 6. Technically, you should erase these vertical lines. I'll let you use them and leave them, just because I know that graphing piecewise functions is probably new to you. All right, we'll start, as we did on the last one, with this dark blue color. And then we'll change colors as we go across. So we're going to graph the first section of it first, which is x squared for x less than, again, but not including -1. So I start to the left of this line, and to the left of this line now I have to think about where I am. I can't just, on number 50, where I could work from my dividing line, the only reason all that worked exactly like it does with a regular graph is that I was at the y-axis, but I'm moved away from the y-axis now for this one. So probably the easiest thing for you to do at your level of comfort with graphing and whatnot is to just think about where you are. So if I go to the left 1, I would be, that would be -1 plugged into x squared, which would give me 1. But it's going to be an open circle because of the fact that it's not or equal to there. And then to the left 1 of this dividing line, I'm at -2, so I plug that in, and that's 4. So I'm going to go up 1, 2, 3, 4. And if I take one more step to the left to get a more accurate graph, I'd be at 3 steps out from the y-axis, so that would be -3 squared would be 9, which would put me here. And then I draw that piece. So it's just the left side of a parabola. And then in the center, we're going to go to, we'll do this one in orange just to throw in a new color. We're going to do the center piece of our piecewise defined function. And now in the middle of this graph, this function says that we're going to have the absolute value of x between -1 and 1. So I start at -1 because now it says or equal to, so I'm going to put a dot wherever the absolute value graph would tell me. Well, if I'm going to graph the absolute value graph, just because I have the y-axis to work from, I know that I'm going to graph its vertex first. And I would go to the left 1 up 1 and to the right 1 up 1. But notice here that on the right end of my interval there, it's not or equal to, so now on the right end, I'm going to put an open circle. And then I would connect those with my little v in the middle. And that's all I have of the absolute value graph. And then we have one more piece to graph, so now let's go green on the right. And now we're going to graph this function. And this is the one you're probably least familiar with of all of these. And this one is, if you have never seen it before, it is in your packet and in your book as one of the functions to know. And the way this function works is, and you can play with it, it's actually in your calculator, but it basically rounds down to the nearest integer beneath it. So if I were to plug in 0.5, I would get 0 because that rounds down. But it says for x greater than 1. So if you think about it, if I go to the right of this second dividing line at 1, then a half step to the right of that, I'd be at 1/2, which would round me down to 0. I'm sorry, no, I'm not at 1. I'm 1.5, not 1/2. 1.5. So that would round me down to 1. So now again, at 1, it's going to give you back the number itself. So that closes in the point that we left open on the first one. And then any value in between on this little interval, and the steps, it's also called the step function, and on this particular step, I'm just drawing a line straight across like that. So if you look in your packet, I did like a zoomed in version of one of the steps so you could see it. So this function will, once I draw that first step, it's easy. From there on out, I'm just drawing them as I normally would. So I'm going to have a step here, and a step here. And for each of those steps, I should have a closed dot on the end, on the left end, and an open dot on the right end. See, and even if you have to make your points bigger to make it obvious that they're open, that's what you should do. So let me go back and fix that last one that looks kind of closed on the end there, because that should actually be a clearly open endpoint. And on this page you see screenshots of each of these two that we just graphed by hand, done on a calculator. And if you're interested in knowing how to graph piecewise functions on the Inspire family of calculators or the 8384 type calculators, refer to the videos specifically about those topics also in the folder. And of course this is number 50 and this was number 52. Okay, that was a 2 in a circle. Try that again. There we go. That's number 52. And that's the end of our examples.